All right, in this video, I'm going to be, looking at the formula for the second derivative of y with respect to x both times, which we use to determine concavity of a parametric curve. And a question I always get is, why do you divide by dx dt, right? We know that the formula is that we find the second derivative of y with respect to x both times by taking the derivative of dy dx with respect to t, because dy dx in this case is the rate of change of y with respect to t divided by the rate of change of x with respect to t. Take the derivative of that, usually involving the quotient rule, and then we divide by dx dt. And, in the past what I've generally shown people is the, mathematically pretty illegitimate way of, multiplying d's and t's and y's and x's and stuff and canceling. But mathematicians know that's not always the most legitimate thing to do, and it's not the most rigorous proof. And when I went searching for, an explanation for somebody that asked me, it wasn't even in my Cal BC class, this was in my multivariable calculus class, where somebody asked me, why do we actually divide by dx dt? I couldn't really find anything on the internet or on YouTube that was super direct as to why do we divide by dx dt. But I knew that somewhere in there I had known why. Okay, and so that's what I'm addressing in this video. Why do we divide by dx dt? So before we go to this big formula I've got here, we need to just go back and remember that the second derivative of y with respect to x both times is found by taking the derivative with respect to x of dy dx. Okay. And so really what we're going to do is we're going to take the derivative with respect to x of, well, we know that dy dx in a parametric context is y prime of t divided by x prime of t. Now, what I'm going to do is I know I need to use the quotient rule, but this is actually an implicit derivative type situation because in the top and in the bottom, I've got two expressions that are going to just have a bunch of t's in them. But I'm taking the derivative with respect to x. So when I take that derivative, I'm going to need to remember that t might have its own derivative with respect to x. And now we're used to taking the derivative of x with respect to t, but this will be, part of why dx dt goes in the denominator. Okay, so I'm going to use the quotient rule. And I know that the quotient rule is bottom times the derivative of the top. Now the derivative of the top is going to be, we're going to take the derivative of the outside while leaving the inside the same, then multiply by the derivative of the inside, which is going to be the derivative of t with respect to x. Bottom times the derivative of the top minus the top times the derivative of the bottom. Well, the derivative of the bottom in the same way is going to be x double prime multiplied by dt dx. Right? It sounds wrong. I never say dt dx, but that's what I need right here. And then divided by the bottom squared. And this is really it. Okay, what I'm going to do is I'm going to factor out that dt dx out into the front. Okay. Like that, and so I've got that dt dx factored out. And okay, now I am kind of relying on a little bit of intuition about d's and t's and x's or whatever, but I don't think it's too much to say that the rate of change of t with respect to x is going to be the reciprocal of the rate of change of x with respect to t. So what I'm going to do is I'm going to kind of flip and multiply, or is that what I'm doing? I don't even know. But I know that, like 1/2 in the numerator is like 2 in the denominator. So what I'm going to do is I'm going to just put that down here. I'll have dx dt. And now, look at what I'm highlighting in yellow. This looks like the quotient rule, right? Bottom times the derivative of the top minus the top times the derivative of the bottom squared. But this is what I would get if I took the derivative of y prime over x prime with respect to t. So what I have is I have 1 over dx dt multiplied by the derivative with respect to t of dy dx. Right, that's what I have in yellow. And I'm dividing by dx dt, which kind of answers the age-old question, why am I dividing by dx dt when I'm doing this? Okay, that's why. It has to do with the quotient rule and the chain rule, I guess both in one. So, that will be it for this short video. I was just really answering one kind of lingering question that's come up in my class